Dear student, welcome to my channel. Topic of this video is classical cryptography. In this video, I am going to explain polyalphabetic and one-time pad substitution methods. Classical encryption technique. They are opposed to modern cryptography and main aim to understand the classical encryption techniques are to introduce the basic concept and terminology of encryption and to prepare us for studying the modern cryptography. So in my previous video I have already explained first four cipher. Now in this video I am going to explain the polyalphabetic and one-time pad. Now let us start. Polyalphabetic cipher. To enhance the security beyond simple monoalphabetic ciphers, different substitution rules are applied throughout the plaintext message. Multiple substitution rule. A set of related monoalphabetic substitution rules is used instead of single one. And next is key dependent selection. A key determines which substitution rule applies at each step. The type of polyalphabetic ciphers are Vigenère Cipher and Vernam Cipher. Vigenère Cipher, it uses a repeating keyword to determine the shift for each letter. The key is applied cyclically if shorter than the plaintext. It provides a better security than monoalphabetic cipher but still breakable. Vernam Cipher, it is also called one-time pad, but there is a difference between Vernam and one-time pad. It uses a random non-repeating key of the same length as the plaintext. If we are using a key if we are using a key only once, then it becomes one-time pad, but over the period if we are repeating keys, then it becomes a Vernam Cipher. Each character is encrypted uniquely, making decryption impossible without that key. Perfectly secure if the key is truly random and never reused. This technique significantly increases the complexity of breaking the cipher compared to simple monoalphabetic encryption. Now first we will see the Vigenère Cipher. It is developed by Blaise de Vigenère in the 16th century. It reduces the effectiveness of frequency analysis by changing the letter mapping. The shift value varies based on keywords. It is secure than monoalphabetic cipher, but now it is breakable with advanced technique. Plain text, ciphertext and key, they are from the set of Z of 26. Here M indicates the length of the cipher, that is secret word, and it is not length of cipher word, it is a length of secret and which will contain the character from 0 to 25. Now here with the example you will immediately come to know the encryption and decryption. So we can see here K1, K2, Km. All of our operations are performed in Z26. For that we require to use the correspond between the alphabet characters and integer. Now see here we are using the keyword cipher. Now this keyword cipher is mapped to the equivalent integers 2, 8, 15, 7, 4, 17. Because A is 0, B is 1, C is 2. So in this way we map. Now here see how we can use the polyalphabetic mapping. Now for example the plain text is this crypto system is not secure. Then our keyword is cipher. So 2, 8, 15. So first what we will do, our plain text is converted into the integer format from 0 to 25. Then we are adding the keyword cipher. So cipher is nothing but 2, 8, 15, 7, 4, 7. So this first keyword, that is the keyword, ends here. Then as our plain text is still there, we are adding the same keyword, next same keyword, next same keyword. For the last we can add only three words or three characters or three letters from the keyword cipher because the plain text having only length of 3. So now we have to observe that in what is the difference between monoalphabetic and polyalphabetic. In monoalphabetic the mapping is always same, but in polyalphabetic the mapping is different. For example, see the word S which is mapped to the 18. Now here when that 7 is get added, the S is mapped to the 25, that is 18 is mapped to the 25. Next time in 18 4 gets added, it maps to the 28. Next time 18 gets added to the 2, it maps to 20. 18 gets added with 17, maps to 9. 18 gets added with 7, maps to 25. Now here we can see that in plain text the character is S, but in output it is mapped to the Z, W, U, J, Z. So that's why the frequency analysis is difficult in polyalphabetic cipher. The strength of the cipher is that there are multiple ciphertext letters for each plaintext letter, one for each unique letter of the keyword. Thus, the frequency information is obscured. But here problem is that now this is not the perfect example because the text is very small, but the keyword is soft and the plain text is software rocks on. So this is input text, their value, key we are repeating again, soft, then cipher, then addition and mod, and this is nothing but output text. Here what we require to check that here keyword is soft, so cryptanalyst or attacker always try to find out the keyword length. So here it is not possible for the to get the keyword length, but sometimes, most of the time, it may happen that whatever this SOFT, they always map to the same character of the plain text. Then we will get the same combination. For example, here I have taken a very partial example. For example, SO, they map with the SO, and next again this SO, again it will map with this SO. So by this way, the attacker will try to find out the length of the cipher, and once the length of the cipher find out, it is very easy to crack the or break the code. Identical plain text sequence with keyword length multiplies yield identical ciphertext. This statement is very important. That is, identical plain text sequence with the keyword length. For example, this soft. Here first time it will match entirely, but next time it will match only with SO. But if it match with the next again same character, then it may happen that the attacker may find out the length of the keyword. Analysts find the repeated ciphertext sequence at a consistent interval. Common factors suggest keyword length. With keyword length M, ciphertext splits into the M. For example, if we use the keyword deceptive, then the encryptive position, if we are getting 1, 10, 19 with the same cipher, then attacker can find out that the length of the keyword is 9. The solution is auto key system, which removes the periodicity by combining the keyword with the plain text, create a running key. So this is the solution, that is nothing but the Vernam Cipher. Vernam Cipher. The Vernam Cipher is a symmetric stream cipher that encrypts plain text by combining it with a key stream of equal length using the XOR operation. This method ensures that each character in the plain text is mixed with the corresponding character from the key stream and producing the ciphertext that appears random. If the key stream is truly random and used only once and kept secret, this cipher is unbreakable, and this is nothing but when this condition is satisfied, it becomes a one-time pad. The same key stream is required for both encryption and decryption because basically methods are of symmetric type. It requires a key stream as long as the plain text, making key management difficult. We will see the encryption process and decryption process. So plain text, whatever the length of the plain text, we require the same key stream. We are using simply XOR operation because when we use XOR operation, decryption process becomes very easy. Now we will see the example. This is the key stream generator which will generate the key continuously, but it should be synchronized at the receiver side also because same keys gate should be generated. Now this is the plain text and key. We are using simply XOR operation to generate the ciphertext, and ciphertext and the same key we get at the receiver, and again XOR operation will reduce to PI. So here XOR operation is very important because here PI, that is ciphertext, is nothing but PI plus KI, that is plain text XOR PI, and when we add again with this ciphertext with again KI, then we will get again the PI. So that is nothing but this operation, that is A is your plain text, B is your key. So plain text XOR key, this is nothing but ciphertext, and when ciphertext again XOR with the key, we will get our plain text. So this is the basic operation. So ciphertext is equal to plain text XOR KI, and again we are adding, we are again make the XOR with the KI, so we will get the plain text PI. Now see simple example. For example, our plain text is hello. So it contains the 5 characters, so we require again the key stream of 5 characters. It is randomly generated. Now here for simplicity I have taken only the example for the first character. Now this is the H and this is the X. These are nothing but their ASCII values. Now we are doing the XOR operation. So this is the result of their XOR operation, and when this XOR again with X, that is nothing but this is nothing but our key, so we will get again H. So decryption is very easy. Again we require to do the ciphertext with our key and we will get the original text. So by using the simple XOR operation we can manage, but only the problem is that we require to generate the key and the length of the key is equal to the length of the plain text, and same key gate should generated at the sender side as well as the receiver side. Next is one-time pad. Improvement to Vernam Cipher proposed by Army Signal Corporation officer Joseph. It uses a random key that is as long as the message, so that key need not be repeated. Key is used to encrypt and decrypt a single message and then it is discarded. This is not case with the Vernam Cipher, but in one-time pad it is strictly discarded. Each new message requires a new key of the same length as a new message. One-time pad offers security but has a lot of difficulties, that is practical difficulties. One is to make the large quantities of random keys. An heavily used system might require millions of random characters on a regular basis. Every message to be sent, a key of equal length is needed by both sender and receiver. So it is very difficult because the encryption system is symmetric. So every key should be shared between sender and receiver, and the length of the key is equal to the length of the message. Because of this difficulty, one-time pad is of limited utility. It is used primarily for the low bandwidth channels which requires very high security. These are the references for this video. Thank you. Now in the next video I am going to explain the Hill cipher, which you require to use variety type of cryptographic mathematical concept like multiplicative inverse. Thank you.